Picture this: a solitary traveler, born in the cradle of a distant star, drifts silently through the infinite void of interstellar space. For millions, perhaps billions of years, it has wandered, untouched by light or warmth, until a fleeting encounter with our sun brings it into focus. This is no ordinary celestial body. This is 3I/Atlas, the third confirmed interstellar object to grace our solar system, and today, on September 2nd, 2025, it has been captured in breathtaking detail by humanity's most advanced eye on the cosmos, the James Webb Space Telescope. What began as a faint blip in the night sky has now been revealed as a cosmic time capsule, a fragment of another world that carries secrets from across the galaxy. This is the story of 3I/Atlas, a tale of wonder, discovery, and the profound questions it raises about our place in the universe. To understand the magnitude of this moment, we must first marvel at the instrument that made it possible. The James Webb Space Telescope, or Webb as it's affectionately called, is not just a telescope, it's a triumph of human ingenuity. Launched on December 25th, 2021, Webb is the successor to the iconic Hubble Space Telescope, but it's far more than a sequel. Positioned a million miles from Earth at the second Lagrange point, L2, Webb floats in the cold vacuum of space, shielded from the sun's glare by a tennis court-sized sunshade. Its 6.5-meter mirror, composed of 18 hexagonal segments coated in gold, captures light with a precision that borders on the miraculous. This engineering marvel, decades in the making, was designed to peer into the farthest reaches of the universe, to witness the birth of galaxies and the atmospheres of distant exoplanets. Yet, in a twist of cosmic fate, it has turned its gaze to a visitor much closer to home, one that hails from beyond our solar system. Webb's infrared capabilities are what set it apart. Unlike Hubble, which primarily observed invisible light, Webb sees the universe in wavelengths invisible to the human eye. This allows it to penetrate clouds of dust, detect faint glimmers from distant objects, and reveal thermal signatures that tell stories of composition and activity. When Webb's instruments locked onto 3I/Atlas, they didn't just capture an image, they unveiled a portrait so sharp, so detailed, that it has rewritten our understanding of interstellar wanderers. This is no blurry snapshot or fleeting streak across the sky. This is a moment frozen in time, a glimpse of a cosmic stranger that has traveled unimaginable distances to brush past our solar neighborhood. Let's set the scene. It's September 2nd, 2025, and astronomers around the world are buzzing with excitement. Just hours ago, Webb's mirrors, perfectly aligned in their cosmic ballet, unfolded their full potential to capture the first high-resolution image of 3I/Atlas. This interstellar object, discovered only recently by ground-based telescopes, is unlike anything that orbits our sun. It follows a hyperbolic trajectory, a path that screams its foreign origins. Unlike comets or asteroids bound by the sun's gravity, 3I/Atlas is a one-time visitor destined to swing through our solar system and vanish forever into the interstellar void. Its name, Atlas, evokes the myth of a titan carrying the weight of the heavens, and in a way, this object carries the weight of cosmic history on its scarred, icy surface. Before Webb, interstellar objects were elusive phantoms. The first 1I/Oumuamua, spotted in 2017, was a slender, cigar-shaped enigma that sparked wild theories. Some even speculated it was an alien artifact. The second, 2I/Borisov, discovered in 2019, resembled a more familiar comet, complete with a glowing tail, but both were fleeting, observed with instruments that struggled to keep up with their rapid passage. By the time astronomers could train their telescopes, these visitors were already receding, leaving more questions than answers. 3I/Atlas, however, is different. Thanks to Webb's unparalleled sensitivity, we now have a front row seat to its journey, and what we see is nothing short of extraordinary. Imagine holding a photograph of a stranger who has traveled across galaxies to knock on your door. That's what Webb's image of 3I/Atlas feels like. The object, several kilometers in diameter, is no mere speck against the stars. It's a resolvable body, its surface a patchwork of light and shadow, ice and rock, scars and secrets. The image reveals a surface that glimmers with reflective patches, volatile ices, perhaps water or methane, sublimating under the sun's faint warmth. These bright spots sparkle against darker regions, where jagged fractures and impact craters tell a story of a violent past. This is no smooth, polished comet comet nucleus like those in our solar system. Atlas is a hybrid, part comet, part asteroid, a relic that defies easy categorization. The most striking feature is the coma, a faint, glowing halo of gas and dust surrounding the object. This isn't the dramatic tale of a solar system comet like Hale-Bopp, but a subtle veil that speaks volumes. It tells us that Atlas, despite its eons-long journey through the frigid emptiness of space, still carries volatile compounds that are now awakening in our sun's presence. This coma is a window into Atlas's soul, revealing that it's not just a dead rock, but an active traveler, releasing material that has been preserved since its birth in another star system. In a sense, Atlas is a time capsule, carrying pristine samples of a distant world's chemistry, untouched by the solar radiation that has altered our own comets and asteroids over billions of years. Webb's spectrographs, which break light into its component wavelengths, add another layer to this portrait. The data reveals a chemical signature that is both familiar and alien. Water ice is abundant, as expected, but it's laced with organic molecules, complex carbon-based compounds rarely seen in our solar system. These molecules are the building blocks of life, the kind that could, under the right conditions, spark the chemistry of biology. The presence of such compounds on Atlas raises tantalizing questions. Are these universal seeds scattered across the galaxy by interstellar travelers? Could objects like Atlas have delivered the ingredients of life to Earth billions of years ago? The image of Atlas isn't just a picture, it's a spark for one of humanity's deepest questions. Are we alone, or are we part of a cosmic web of life? To fully appreciate Atlas, we need to imagine its journey. Picture a young star system millions of years ago, far from our own. Perhaps it was a chaotic place, with giant planets migrating through crowded orbits, scattering debris like cosmic billiards. Or maybe a nearby star passed too close, its gravity tearing objects loose from their parent system. Somewhere in that distant drama, Atlas was born, a chunk of ice and rock forged in the outer reaches of a star's influence. A gravitational slingshot sent it hurtling into interstellar space, where it drifted in darkness, untouched by light or heat for eons. Its journey to our solar system is a statistical marvel. The galaxy is vast, and the odds of an interstellar object passing within observational range are vanishingly small. Yet, Atlas found its way here, drawn by the sun's gravity for a brief encounter before continuing its endless voyage. Webb's precise measurements of its trajectory confirm its interstellar origins, a hyperbolic path that will never loop back. This is a one-time visit, a cosmic cameo that we're lucky to witness. The poignancy of this fleeting encounter adds to its allure. Atlas is a stranger we'll never meet again, but in this moment, it's as close as it will ever be, and Webb has immortalized it in stunning detail. Let's dive into the science behind this discovery, because it's nothing short of revolutionary. Unlike Oumuamua, which was a mere few hundred meters long, or Borisov, a small comet-like body, Atlas is a behemoth, measuring several kilometers across. Its size suggests it survived its ejection from its parent system intact, a testament to its resilience. This makes it a rare specimen, a full-fledged comet nucleus, not a fragment, carrying a wealth of information about its origins. The surface, as revealed by Webb, is a geological mosaic. Bright patches of ice contrast with dark, carbon-rich regions, hinting at a complex history of accretion and bombardment. The irregular shapes and scars suggest impacts from its travels, perhaps from micrometeorites or larger collisions in its home system. The coma, that faint halo of gas and dust, is particularly telling. It indicates that Atlas is actively outgassing, releasing volatile compounds as it warms under the sun's influence. This activity is a goldmine for astronomers, as it provides a direct sample of material from another star system. The spectrographic data points to water ice, but also to exotic organics, molecules with carbon chains and structures that differ from those in our solar system. These compounds could be relics of a star-forming region with different elemental abundances or radiation profiles. Some may even be entirely new to science, offering chemists a chance to study the building blocks of alien worlds. The rotational dynamics of Atlas add another layer of intrigue. Unlike the predictable spins of many solar system bodies, Atlas tumbles chaotically, its brightness varying as it rotates. This irregular motion could be the result of its violent ejection or the cumulative effects of outgassing and impacts over millions of years. By studying this tumble, astronomers can infer the forces that shaped Atlas's journey, from gravitational encounters to the subtle push of sublimating gases. This dynamic behavior sets Atlas apart from our local comets and asteroids, which are often stabilized by long-term gravitational influences. The discovery of 3I/Atlas is more than a singular event. It's a window into the ecology of our galaxy. The Milky Way is not a static collection of stars and planets, but a dynamic ecosystem where material is constantly exchanged. Stars form in dense clusters where gravitational interactions fling debris into interstellar space. Giant planets migrate, scattering icy bodies from their orbits. Supernovae and stellar flybys stir the cosmic pot, sending objects like Atlas on their lonely journeys. Webb's image of Atlas confirms that interstellar space is not empty, but alive with travelers, each carrying a piece of its home system's story. This realization reshapes our understanding of galactic connectivity. If kilometer-scale objects like Atlas can cross the void intact, how many others are out there, drifting unseen? The galaxy may be a highway of nomadic bodies, silently shuttling material from one star system to another. This raises profound questions about the origins of life. If Atlas carries organic molecules, it's evidence that the ingredients of biology are not confined to one star, but are scattered across the cosmos. Could such objects have seeded Earth with the chemistry that led to life? Could they be doing the same on distant exoplanets? Webb's image of Atlas is a cornerstone in this debate, offering tangible proof of a delivery mechanism for life's building blocks. Consider the broader canvas of the Milky Way, where 3I/Atlas is but one thread in a vast, shimmering tapestry. Every star system is a story, a unique experiment in cosmic architecture, with its own planets, comets, and cataclysms. Atlas, with its scarred surface and exotic chemistry, is a chapter torn from one such story, carried across light years to intersect with ours. Its presence challenges us to think of the galaxy not as a collection of isolated dots, but as a living network where material flows like rivers between stars. The patches of ice on Atlas's surface may have formed in the glow of a star unlike our sun, perhaps one hotter or cooler, younger or older. The dark scars could be the remnants of collisions in a crowded protoplanetary disk, or the marks of cosmic rays encountered during its long exile. Each feature is a clue, a fragment of a narrative that began long before Earth existed. Webb's image transforms this abstract idea into something tangible, a snapshot of a galactic ecosystem where stories are written in ice, rock, and light. By studying Atlas, we're not just observing an object, we're reading a letter from another star delivered across the ages. The image of 3I/Atlas also ignites dreams of a future where humanity doesn't just observe, but reaches out to touch these cosmic travelers. Imagine a spacecraft, sleek and swift, racing to intercept an interstellar object like Atlas. Such a mission, though decades away, is no longer pure science fiction. The success of Webb proves we can detect and study these visitors in detail, paving the way for ambitious projects. A probe could analyze Atlas's surface up close, collecting dust from its coma, or even landing to drill into its icy crust. The data from such a mission would be a treasure trove, revealing not just the composition of an alien object, but the conditions of the star system that birthed it. Webb's image is a stepping stone, a reminder that these fleeting visitors are within our reach, if we dare to chase them. The technological hurdles are immense, from rapid launch capabilities to propulsion systems that can catch a fast-moving target, but the spark of possibility is now lit. Atlas, in its silent passage, calls us to imagine a day when we can hold a piece of another star system in our hands, bridging the vast distances of the cosmos with human curiosity. There's something deeply moving about the image of 3I/Atlas, a feeling that lingers long after the scientific details fade. It's the sense of connection to something far greater than ourselves, a reminder that our small planet is part of a grand, restless universe. To look at Atlas is to feel the weight of time, millions of years compressed into a single frame, a journey that began in a distant star's embrace and ends, for now, in our gaze. It's humbling to know that this object, forged in a place we'll never see, has crossed the void to meet us, if only for a moment. Its fleeting presence mirrors our own existence, brief on cosmic scales, yet capable of profound impact. Webb's image captures this duality, blending awe with intimacy, vastness with immediacy. It invites us to pause, to wonder, and to feel the quiet thrill of being part of a galaxy that is alive with motion and mystery. Atlas is not just a scientific discovery, it's a mirror reflecting our own longing to explore, to connect, and to find meaning in the stars. The observation of 3I/Atlas by Webb is a catalyst that reverberates far beyond astronomy, igniting a cascade of insights across multiple disciplines. For planetary scientists, Atlas is a Rosetta Stone, offering a direct sample of material from another star system to compare with our own comets and asteroids. Its hybrid nature, part icy comet, part rocky asteroid, challenges existing models of planetary formation, suggesting that the processes shaping worlds may vary widely across the galaxy. Chemists are equally enthralled as the exotic organic molecules detected on Atlas's surface open new avenues for studying cosmic chemistry. These compounds, preserved through eons of interstellar travel, could reveal how complex molecules form in alien environments, potentially rewriting our understanding of prebiotic chemistry. For astrobiologists, Atlas strengthens the case for panspermia, the idea that life's building blocks are distributed across the cosmos by objects like this one. Beyond the sciences, the discovery inspires engineers to dream of new technologies, probes capable of chasing interstellar visitors, or telescopes with even greater sensitivity than Webb. Even in the humanities, Atlas sparks philosophical debates about our place in a universe where matter flows freely between stars, blurring the lines between ours and theirs. This single image, captured on September 2nd, 2025, is a nexus of human inquiry, uniting fields as diverse as geology, chemistry, biology, and philosophy in a shared quest to decode the story of a cosmic wanderer. To fully grasp the significance of Atlas's image, we must pause to appreciate the technological symphony that is the James Webb Space Telescope. This is no ordinary instrument. It's a masterpiece of precision engineering, a delicate dance of physics and craftsmanship performed a million miles from Earth. Each of Webb's 18 mirror segments, meticulously aligned to within a fraction of a human hair, works in harmony to collect photons that have traveled across interstellar distances. The sun shield, a 5-layer marvel thinner than a sheet of paper, maintains the telescope's instruments at temperatures colder than negative 370 degrees Fahrenheit, ensuring they can detect the faintest infrared signals without interference. The mid-infrared instrument, MIRI, which played a key role in capturing Atlas's thermal signatures, is a technological wonder in itself, cooled to near absolute zero to avoid its own heat contaminating the data. The deployment of Webb, from its launch atop an Ariane 5 rocket to the unfolding of its mirror and sunshield in space, was a high-stakes choreography that unfolded flawlessly over weeks. Every pixel of Atlas's image is a testament to decades of collaboration among thousands of scientists, engineers, and technicians across multiple continents. This achievement, realized on September 2nd, 2025, is not just a snapshot of a cosmic object, but a celebration of human ambition, a reminder that when we dare to build tools that reach for the stars, we can capture moments that redefine our understanding of the universe. The image of 3I/Atlas does more than illuminate the mechanics of the cosmos. It holds up a mirror to humanity itself. In its scarred, icy surface, we see a reflection of our own journey, a species born on a small planet driven by curiosity to explore the unknown. Atlas, with its chaotic tumble and ancient scars, embodies resilience, a quality we recognize in our own struggles to overcome challenges and reach beyond our limits. Its fleeting visit reminds us of the impermanence of our existence, yet its capture by Webb underscores our capacity to create moments of permanence through discovery. This interstellar object, born under a different star, speaks to our shared origins in the cosmic furnace of the Big Bang, where all matter was forged. It challenges us to see ourselves not as isolated beings, but as part of a galactic narrative, connected to every star and every world through the material that flows between them. The emotional weight of this realization is profound. It stirs a sense of humility, wonder, and responsibility to continue exploring, to keep asking questions, and to preserve the fragile planet that allows us to gaze at such wonders. As we study Atlas, we're not just learning about a distant object, we're learning about our own potential to bridge the vastness of space with the power of our collective imagination. Beyond the science, the image of 3I/Atlas resonates on a deeply human level. To look at this object is to see a fragment of another star system, a piece of a world we'll never visit. It's a reminder that our solar system is not an isolated island, but part of a vast galactic tapestry woven together by the movement of matter. Atlas is both alien and familiar, a stranger that feels intimately connected to our own story. Its scars and ices tell a tale of endurance, of a journey that spans millions of years years and countless light years, only to intersect with our gaze for a fleeting moment. This discovery also speaks to the human spirit of exploration. The image of Atlas is a testament to what we can achieve when we push the boundaries of technology and imagination. Webb itself is a marvel, a machine that took decades to design, build, and deploy. Its success is a collective triumph, uniting engineers, scientists, and dreamers in a shared quest to understand the cosmos. Every pixel of Atlas's image is a victory, a reminder that humanity can reach beyond our world to touch the stars, even if only through light. Philosophically, Atlas challenges us to rethink our definitions of home and foreignness. It's an object that doesn't belong to our sun, yet for this brief moment, it's part of our story. It blurs the boundaries between systems, reminding us that the universe is a continuum of interactions, not a collection of isolated dots. Atlas is a symbol of impermanence, a traveler that will soon be gone, but also of connection, linking us to a distant star through the light it reflects. Its image captures the paradox of our existence, fleeting on cosmic scales, yet capable of leaving an enduring mark through discovery. The capture of 3I/Atlas is not an endpoint, but a beginning. It's a spark for future exploration, both observational and physical. Astronomers are already refining their models of Atlas's composition, rotation, and thermal properties, building a detailed portrait of this interstellar visitor. These findings will inform future surveys, as observatories like Webb prioritize the rapid detection of other interstellar objects. The more we learn about these travelers, the better equipped we'll be to catch them early, maximizing the data we can collect. The image also fuels ambitions for direct exploration. While today we observe Atlas from afar, the future may bring missions to intercept such objects. Imagine a probe racing to meet an interstellar visitor, collecting samples of its surface or analyzing its coma up close. Projects like Breakthrough Starshot, which aims to send nanocraft to nearby stars, are still decades away, but interstellar objects like Atlas offer a more immediate target. They're fragments of other systems passing through our backyard, and with the right technology, we could touch them, bridging the gap between distant observation and hands-on exploration. Webb's success with Atlas also sets the stage for future telescopes. Instruments like the proposed LUVOIR or HABEX will build on Webb's legacy, offering even sharper views and broader wavelength coverage. These observatories could reveal entire populations of interstellar objects, transforming our understanding of galactic debris. Atlas is a herald of this future, a proof of concept that we're ready to study the galaxy's nomads in depth. As we reflect on the image of 3I/Atlas, it's worth pausing to consider what it represents. This is not just a scientific achievement, but a cultural and philosophical milestone. It's a story etched in ice and rock, a tale of a journey that began in the fires of a distant star and ended for a moment in our gaze. Atlas is a reminder that the universe is alive with movement, connection, and possibility. It's a call to look up, to wonder, and to keep pushing the boundaries of what we believe is possible. The James Webb Space Telescope has given us more than an image. It's given us a connection to the cosmos. 3I/Atlas, with its scarred surface and glowing coma, is a messenger from another star, a fragment of a world we'll never see but can now begin to understand. Its story is our story, a reminder that we are part of a galaxy that is dynamic, interconnected, and brimming with mysteries waiting to be explored.